Given the hypotheses where the variance is either equals to 1, that's in the null hypothesis, or in the alternative hypothesis, the variance is not equals to 1, which would make this a two-tailed test. Whenever you have equals, not equals, we're going to see a two-tailed test. So our distribution is going to be with a lower tail and an upper tail. And so we're going to have two rejection regions. There's going to be some lower value here, which is given by chi-squared 1 minus alpha by 2. And degrees of freedom also help define that. This one is chi-squared and alpha divided by 2. Degrees of freedom are also going to help define that. They say if the sample size is 100, so we have n equals to 100, the rejection region is, okay, so we're already part of the way to figuring that out. Let's have a look. Now, 1 minus alpha divided by 2. Do we know what alpha is? Did they actually mention anything about alpha? Yes, they did. They told us that alpha is 0.05. So if alpha is 0.05 and half of alpha, then would be 0.025. That's going to help us fill in these values here. So this is going to be chi-squared dependent upon 1 minus 0.025. And our degrees of freedom are just n minus 1. So that's 100 minus 1. Our degrees of freedom will be 99. So I need to use 1, actually let's rewrite this. 1 minus 0.025 is equals to 0.975 and 99 degrees of freedom. So I'm going to look up this rejection region. And this one here is chi-squared dependent upon half of alpha. We know that that is 0.025 and the degrees of freedom are 99. Okay, so we also have to look up this one. So we're going to be using degrees of freedom 99 in both cases. We need to look at the 0.975 column and the 0.025 column. So I've got the chi-squared table here. Now you can see that we've got the 0.975 column there and the 0.025 column there. But as far as the degrees of freedom go, we need to go down a little bit to get to our 99 degrees of freedom. Now, of course, 99 degrees of freedom are not in here. It jumps from 90 to 100. 100 is much closer, so I'm going to use that row. I'm going to use that last row here. And it was 1, 2, 3 columns in that gave us the 0.975 column, and it was 3 rows in here that gave us the 0.025 column. So I have 74.22 and 130. So this is 74.22 and this is 130. So in other words, I'm going to say that we should reject the null hypothesis if chi-squared is less than 74.22 or if chi-squared is greater than 130. So I'll need to see if that shows up as one of the possible answers. Okay, so I don't see any of these, so it's going to have to be none of the above. So the correct answer here is D.